Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.12. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.12. Find the value of voltage V0 in given below figure using nodal analysis. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 1 kilo ohm resistance labeled as V0. So without wasting time, let's proceed towards the solution. We know that in order to solve nodal analysis problem, we have to follow some steps. The first step includes labeling the all node voltages. In this network, we will label these node voltages as V1, V2 and V3. Inside this network, if we observe, there is a voltage source exists between two non-reference nodes. So we cannot solve this problem using simple nodal analysis technique. In order to solve this problem, we have to adopt supernodal analysis technique. In this technique, we have to make a supernode on this point by merging this voltage source to either this node or this node. I have made a separate video related to the concept of supernode analysis. In that video, I also teach how to make a supernode. So I will strongly recommend you to see that video before solving this problem. Link of that video is given in below description. As we discussed earlier, we have to merge this dependent voltage source to either its corresponding node in order to make supernode on this point. First of all, we will write mathematical form of these two node voltage potential difference. Potential difference V1 minus V2 between these two nodes will be equal to 4kIx. Here we have assumed voltage V1 is on higher potential than V2. So the direction of current will be from V1 to V2. Current entering terminal of this voltage source is positive. That's why the value of this dependent voltage source is taken with positive sign. Now we want to merge this voltage source to V2. In that case, V2 using this equation will be equal to V1 minus 4k times Ix. We have found the equation of node voltage V2 after merging this voltage source to this node. So we will modify this network by making a supernode on this point and replacing V2 with its corresponding equation. V2 is replaced with V1 minus 4kIx. Now this supernode will act as a single non-reference node for this network. In next step, we have to assume and label all unknown branch currents along with their directions. We have assumed all of these three branch currents are leaving from these respective nodes, and these currents are labeled as I1, I2 and I3. Total number of non-reference nodes inside this network is 2. One is supernode and other one is this node V3. So there will be two node voltage equation for this network. We will start writing Kirchoff's current law equation on this supernode. On this node, two currents are entering. One is 8 mA and other one is Ix. While three currents are leaving, I2, I1 and 2 mA. All leaving currents are taken with negative sign. In next step, we have to replace these currents with their corresponding equations. Current I1 will be equal to V1 divided by 3 kilo ohm. Similarly, current I2 will be equal to voltage across this 6 kilo ohm resistance, that is V1 minus 4k times Ix divided by the value of resistance. Current Ix is moving from node V3 to this supernode. So the equation of this current will be V3 minus node voltage of this supernode divided by the value of resistance. V3 minus V1 minus 4k times Ix divided by 2 kilo ohm. First of all, we will subtract 2 milliampere from 8 milliampere. It will become 6 milliampere. And will multiply this equation with 6 kilo ohm in order to omit all denominator values. Product of 6 kilo ohm and 6 milliampere will result 36 volt. Here 6 kilo ohm will cancel out with 3 kilo ohm, only 2 will left, and that 2 will be multiplied with V1, it will become 2V1. Similarly, here 6 kilo ohm will cancel out with 6 kilo ohm in denominator, only V1 minus 4k times Ix will left. Here 6 kilo ohm will cancel out with 2 kilo ohm, only 3 will left, and that 3 will be multiplied with this value. Now open these brackets, this minus will multiply with values inside the brackets, it will become minus V1 plus 4k times Ix. Similarly, this 3 will multiply with values inside the brackets, it will become 3V3 minus 3V1 plus 12k Ix. Place 36 volt on the other hand side of equal in order to separate it from variables, and sum of minus 2V1 minus V1 and minus 3V1 will become minus 6V1. Sum of 4kIx and 12kIx will become 16kIx. We cannot further solve this equation, so we will leave this equation as it is and will label this equation as equation A. It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. On this node, one current is entering 2 milliampere while two currents are leaving I3 and Ix. Now replace I3 and Ix with their values. I3 will be equal to voltage across this 1 kilo ohm resistance V3 divided by the value of resistance 1 kilo ohm. Similarly, Ix is equal to V3 minus V1 minus 4k Ix divided by 2 kilo ohm. Now open these brackets, it will become minus V1 and plus 4k Ix, and multiply this equation on both sides with 2 kilo ohm in order to omit all denominator values. Product of 2 milliampere and 2 kilo ohm will result 4 volt. Here product of 2 kilo ohm will cancel out with 1 kilo ohm in denominator. Only 2 will left, and that 2 will be multiplied with V3. It will become 2V3. Here the product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator. Only nominator value will left, V3 minus V1 plus 4k Ix. Now open these brackets. Minus will multiply with values inside the bracket. It will become minus V3 plus V1 minus 4k Ix. Arrange this equation. Minus V3 and minus 2V3 will become minus 3V3, and place constant value on the other hand side of equal to separate it from variables. We cannot further solve this equation, so we will label this equation as equation B, and it is the second node voltage equation of the network. Up to this point, we have retrieved two node voltage equations from this network. Now we will further solve these equations in order to find the value of voltage V3. We are interested to calculate the value of voltage V3 because it is appearing across 1 kilo ohm resistance. Voltage V0 is also appearing across 1 kilo ohm resistance. So indirectly we can say that V3 will be equal to V0. And we are interested to calculate the value of V0 as it is asked in this scenario. These both equations have multiple variables V1, V3 and Ix. So if we replace the value of Ix inside this equation, one variable will be reduced. So first of all, we will try to find the equation for current Ix. Current Ix is equal to the potential difference between these two node voltages divided by the value of resistance V3 minus this supernode voltage V1 minus 4k Ix divided by the value of resistance 2 kilo ohm. Now multiply on both sides with 2 kilo ohm and open these brackets. The equation will become 2k Ix is equal to V3 minus V1 plus 4k Ix. Now swap the position of these two variables with this variable. The equation will become V1 minus V3 equal to 4k Ix minus 2k Ix. This 2k Ix is placed on the right side of equal. It is converted into minus 2k Ix. Similarly, these two variables signs are also changed whenever we have placed these variables on the left side of the equal. Now subtract 2kix from 4kix, the equation will become v1 minus v3 equal to 2kix. In order to find the value of current ix, we will divide on both sides with 2k. Equation for current ix will become v1 minus v3 divided by 2k. Now we will place the value of current ix in these both equations. First of all, we will place this value in equation A. Ix is replaced with V1 minus V3 divided by 2K. Here the product of 16 kilo will cancel out with 2 kilo in denominator. The equation will become minus 6V1 plus 3V3 plus 8 into V1 minus V3 equal to minus 36 volt. Now open these brackets, multiply 8 with variables inside the brackets. The equation will become minus 6v1 plus 3v3 plus 8v1 minus 8v3 equal to minus 36 volt. Add same variables together. Sum of 8v1 and minus 6v1 will become 2v1 and sum of minus 8v3 and plus 3v3 will become minus 5v3. We will leave this equation for now and label this equation as equation D. Now we will replace current Ix with its equation in equation B. Ix is replaced with V1 minus V3 divided by 2K. Now the product of 4K will be cancelled out with 2K in denominator. Only 2 will left and that 2 will be multiplied with these variables. Open these brackets and take the product of minus 2 and V1 minus V3. It will become minus 2V1 plus 2V3. Now arrange the equation. Take the sum of minus 2V1 and V1, it will become minus V1. Similarly, minus 3v3 and plus 2v3 will become minus v3. We will label this equation as equation E. Now these both equations have two variables. One of them is v1 and other one is v3. We are interested to calculate the value of v3. For that purpose, we will take equation D as it is and multiply this equation E with 2 and add that resulting equation to equation D. Product of 2 with this equation E will be minus 2v1 minus 2v3 equal to minus 8 volt. Now add these equations together. The sum of 2v1 and minus 2v1 will cancel out with each other. Sum of minus 2v3 and minus 5v3 will become minus 7v3. And here sum of minus 36 volt and minus 8 volt will become minus 44 volt. Now divide on both sides with minus 7 in order to calculate its value. That will become 6.28 volt. And because V3 was equal to V0, so we can say that the value of voltage V0 inside this network is 6.28 volt. So this was chapter 3 learning assessment E3.12. Thank you. See you again in next video.